Hello everyone, Mr. Boltri here bringing you video 2.4 where we're going to be talking about position versus time graphs. So in our last class, we did the Buggy Lab debrief. So a lot of this should be review, but I wanted to make a video so that you could go back and rewatch it in case anything was confusing or we didn't get the exact perfect answers in class. So on the left, I have the position versus time graph for two different buggies, one that was done by the blue team and one that was done by the green team. So in our class, we talked about what was the meaning of the slope of these graphs and what was the meaning of the vertical intercept of these graphs. Why are the slopes different? Why are the vertical intercepts different? And in class, we got to the answer that the slope was how many tiles the cart moves per each 1 second. So 1 second that goes by, the carts are moving a certain amount of tiles. They're covering a certain distance traveled or experiencing a displacement every 1 second, because remember, slope is over 1. So let's say it's 1.5. We could write that as 1.5 tiles over 1 second. So that means it's moving 1.5 tiles each 1 second that goes by. So then the vertical intercept is where the buggy started at 0 seconds, the position where it started. So this is 0 seconds. This one has a position of 5 tiles. 0 seconds, this one has a position of 3 tiles to the left of the origin, or -3 tiles. So it's good to understand sort of like what each of these mean before we transition to the vocabulary word for each of these. But we do have a vocabulary word for each of these two terms. So how many tiles something moves in 1 second, we call the velocity. Because remember, this slope is also negative. So the velocity, the slope includes the direction. So that's how we know it's velocity and not speed. And the word that we have for the position where something starts, we just call that the initial position. So make sure that you understand that for a position versus time graph, not any graph, but only a position versus time graph, the slope is the velocity and the vertical intercept is the initial position. So based on this information, can we find the equation for velocity? Well, if we know that the velocity is the slope of a position versus time graph, and we remember that to find slope, it's just rise over run for a position versus time graph. So velocity is going to be the rise, which is the change in the vertical variable. So since our vertical variable is position, it's going to be the change in position divided by the run, which is the change in the horizontal variable, which in this case is time. So it's going to be the change in position over change in time. And just like that, we have an equation that we can use for velocity. But please recognize that this equation is just exactly the same thing as the slope of a PT graph, or position versus time graph, which we've said is velocity. So these three things all mean the same thing: velocity, this equation, and slope of a position versus time graph. So we've been talking about velocity a lot, but what about speed? Oh, how does speed factor into this? So remember that speed is the same as velocity, except with velocity, it's speed with a direction. So for speed, we don't care about the direction. So how you would see that on this position versus time graph is we would look at the magnitude or absolute value of the slope. So you would find that this one has a small slope. I think it was like 0.5. And this one has a big slope. It was like -1.5. But for the speed, we don't care about the negative. So this has a speed of 1.5 tiles per second. This has a speed of 0.5 tiles per second. So another way that you could figure that out is, let's say you weren't given numbers on this graph. You were just given a blank grid and asked which one is going faster. Well, we don't care that this one is going down and this one is going up. All we care about is which one has a steeper slope, because the steepness represents the magnitude of the slope, and the magnitude of the slope for a position versus time graph is the speed. Because since we're looking at magnitude, that takes away the direction, so it's no longer velocity, now it's speed. And what about displacement? How can we figure out displacement using this position versus time graph? Well, remember, displacement is a measure of how far you are from where you started. So on a position versus time graph, we can figure out how far you are from where you started because we just have a bunch of positions. So let's go from 0 seconds to 5 seconds. This one started at a position of 5 tiles and ended at a position of -3 tiles. So we can just look and see that it moved 1, 2, 3, 4, 5, 6, 7, 8 tiles to the left. Now, a lot of people are going to be tempted to say this moved 8 tiles down because it's moving down the graph. But remember, this is a graph showing an object that was moving to the left and to the right. So when it goes down in the negative direction, we have to remember that the negative direction is to the left. So this moved 8 tiles to the left, or negative 8 tiles. So remember, displacement is how far you are from where you started. And we can find that using a simple formula, which is just the final position, -3, minus the initial position, so -5. -3 minus 5 is going to give us -8. So this is just the equation to do exactly what we just talked about. Let's try a different one. Let's go from 0 to 5 seconds for this green line. So it starts at -3 and then moves up to -1. So we can see just pretty easily it has a displacement of 1, 2. So this counting bumps method works because our scale is only 1 tile at a time. But if the scale is different, we're going to probably want to use the equation. So final position is -1 minus the initial position is -3. -1 minus -3 is going to be +2, and that gives us the displacement. So this has been a refresher of hopefully what you were already understanding in class, but we're going to do even more practice problems with position versus time graphs in our next class, which should make us fully prepared for the quiz on standard 2A. And then we're going to start talking about velocity versus time graphs to get us ready for standard 2B, both of which are going to be coming up soon. So make sure that you're checking out the course calendar for upcoming quiz dates. But if you have any questions, please, as always, do let me know. And for right now, I'm going to go ahead and wrap up video 2.4, where we're talking about position versus time graphs. Looking forward to doing some practice problems with you in our next class, and go Bears.